Hello everyone. The title of this video is Solve Equations in Quadratic Form. Every exercise I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 9.4 titled Solve Equations in Quadratic Form, and I'm working under the heading in the exercises with the same title. Now I'm only going to be working on the even numbered exercises, so number 156, 158, 160, and so on, all the way to exercise 192. So it's quite a bit. All right, and these are the exercises that don't have solutions in the text. Right, you may notice that the odd numbered ones have a link on them. If you click on that link, you can see the solutions to those exercises, but I'm doing the even ones. I'll also be putting timestamps for each of these exercises in the description of this video. All right, and so if you look at the timestamps below, you'll see example 1. Right, example 1 corresponds to number 156, example 2 to number 158, example 3 for 160, and so on. Alright, so if there's a problem you'd like to see right away, just count down how many examples that would be and click on that particular timestamp. Alright, and one other thing I request of you is that when I bring up a new question, pause the video and try to do it yourself first before watching me doing it, and then compare. Because if you're just watching me do these questions without practicing yourself, chances are you're not learning all that much. Alright, great. Alright, so the first question is exercise 156, and I have these written out. Alright, so you see example 1, number 156 in the text. And yeah, we're just asked to solve these equations, right? Find the solutions, find the numbers that I can replace the variable with to make a true statement. So this first one is x to the fourth minus 9x squared plus 18 equals 0. Now this is not a quadratic equation. This is what they would call a quartic equation. Right? The highest power on x is x to the fourth. So it's not a quadratic equation, but it is like a quadratic equation. So we're going to be looking at equations in quadratic form in this video, which I'll talk about over here. Equations in quadratic form. These are equations that can take the form a times u, where u is some variable expression, to the 2 times n power, right, where n is an integer. And I'll write all this stuff out after I'm done with the form, plus b, where b is a number, times this same u, this same expression, to just the 1n power, plus, and then some constant c, equals 0. Alright, this is where a, b, and c are real numbers. U is a variable expression. and n, well, n is also a real number. I know I said it was an integer earlier, but n is a real number as well. Maybe I should have put r for a real number, but okay. So basically, if you can get an equation in this form here, they'll say it's quadratic in form. So you've got three terms added together on the one side equals 0 on the other, and the power on the first term is double the power of the second term, just like a quadratic. And what we're going to do to solve these things is make a substitution. All right. So you would substitute replace the u to the nth power, replace it with just say x or whatever variable you want. All right. If you do this, it transforms our equation in quadratic form into an actual quadratic equation. If I replace u to the n with x, then this expression, this equation becomes a times u to the 2n is u to the n squared, right, using the power to a power property. So that would become x squared, or whatever variable I use to substitute squared, plus, and then b times, and again, u to the nth power I'm replacing with x plus some constant c equals 0. And look, if you make such a substitution, it transforms the equation in quadratic form into an actual quadratic equation. All right. So then you solve the resulting quadratic equation, which you should know how to do by now. Solve the resulting quadratic equation. So you could use the quadratic formula. You can use completing the square, factoring if possible. Then finally, substitute back and solve for the original variable. Substitute back and solve for the original variable in the problem. And then of course check your solutions, right? I shouldn't have to write this, but you should always be doing this when working with equations, right? Solving equations. Always check your solutions back in the original equation, back in the original statement. Alright. So here's how we're going to solve these equations in quadratic form. Now let me show you that this first equation here, it's not quadratic, but it is in quadratic form. See, x to the fourth is actually, the same thing as x squared squared. Right? Then you have minus 9 times, and then I'm just putting parentheses around it so I can highlight it. X squared is x squared to the first, and then plus 18 equals 0. Do you see how this is in this form? You have, some expression to a power that is double that same expression in the next term to that that first power. the power on that expression in this term is double the power on that same expression in this term, right? U to the 2n, u to the n. Right? The power on the expression in the first term is double that power on that same expression in the second term. I hope that makes sense. And then we have plus some constant, right? Plus 18 equals 0. This takes on that form exactly. Okay, so now I just replace x squared here, right? This expression being squared into the first power. Right? So we're going to substitute. I'll write this in a different color. I'm going to substitute. I'm going to replace all the x squareds in this equation with some other letter, right? Some other variable. And you can do whatever you want. How about m? It doesn't matter, right? As long as it's not x again, right? Don't use the same letter multiple times. Alright, so if I do this, well then x squared squared becomes m squared. Minus 9 times x squared becomes m. And then you have plus 18 equals 0. And now look, this is now a quadratic equation in this new variable m. So then after I make the substitution, turn it into a quadratic equation, and then we solve this quadratic equation, right? I'm going to solve for m. So this is factorable. This is actually a pretty nice one. Right, this factors to m minus 6 times m minus 3. Right, and then by the zero product property, you can say that m must be 6, or m could be 3. Right. But that I'm not done. Right, I'm not done. I'll put some more paper here because I'm running out of room. Not finished. Right, I've solved for m. That solves this equation. But the original equation had x as the variable. So now that I know that m can be 6, m can be 3, we substitute back. So, m equals 6. Well, remember, m is x squared, so this is the same thing as saying x squared equals 6. And m equals 3. M was x squared, remember? This is the same thing as x squared equals 3. And then I solve these, right? Solve for the original variable, right? Solve for x. Well, these are pretty simple, right? I can use the square root property to solve both of these. Here, x equals, positive square root of 6, or x equals negative square root of 6. Right, solve that equation. And over here, x equals positive square root of 3, or x equals negative square root of 3. And then now I have my possible solutions. Now we check them, right? And you always check back in the original equation. Right? Now square root of 6. Now when I raise the square root of 6 to the 4th power, that would be 36, and I'll leave it to you to figure that out. The square root of 6 to the 4th power is 36. The square root of 6 squared is just 6, and 9 times 6 is 54. 36 minus 54 is negative 18, plus 18 is 0. So, and same would go for negative square root of 6, because these are to the even powers. So a positive number, a negative number to an even power will give you the same results. So both of these work. Right? The square root of 6 is a solution, and so is negative square root of 6. Plug in the square root of 3. The square root of 3 to the 4th power would be, 9. And again, I leave it to you to check that. It'd be 3 times 3, 9. So that's 9, and then the square root of 3 squared is 3. Negative 9 times 3 is negative 27. 9 minus 27 is negative 18, plus 18 is 0. So both of these would work as well. So there are 4 solutions here. Square root of 6, negative square root of 6, square root of 3, and negative square root of 3 all work. Wonderful. But yeah, so this is how we're going to work on all these questions. I'm going to try to see how is it in this quadratic form. Make a substitution to turn it into a quadratic equation with a new variable. Solve this quadratic equation, for this new variable, and then substitute back and solve for the original variable and check solutions. Right? It's a lot of steps, but it'll work every single time for the exercises I'm going to see here in this video. Alright, wonderful. So let's do that again. Alright, so again, just so you don't forget, x equals positive or negative square root of 6, x equals positive or negative square root of 3, right, ended up being the solutions here to number 1. So those are on a separate page now. Alright, so question 2, very similar. It's another degree 4 equation, another quartic equation, but you got everything on one side, 0 on the other. Notice that the power in the first term is double the power on the second term, and then you have a constant. So this must be in this quadratic form, and I'll show you how. So once again, x to the 4th is x squared squared, right, written as a square, plus, and then we have 5 times, and then here we have x squared to the 1st, but no need to write to the 1st, and then minus 36, right, equals 0. Right. So I can definitely see that it's in quadratic form. Now I will replace these x squareds and actually turn it into a quadratic equation. Right, so let's substitute. I'm going to replace the x squareds with n this time. Why not? It doesn't matter. It doesn't matter. As long as it's not x again. Right? You don't want to double up on the original variable. Now if I make this substitution, this becomes n squared plus 5n minus 36 equals 0. And then we solve this new equation for n. Right. So this factors, this is n plus 9 times n minus 4. So my solutions in n, this new variable, are n equals negative 9 or n equals positive 4. Alright, but again, these are not the solutions of the original equation, right? The original equation had the variable x. So we substitute back. And I'll write that again here. Substitute back, right, go back to expressions with the original variable x. Remember, n was replacing x squared. So this first equation here is x squared equals negative 9. And this equation here, n equals 4, is now x squared equals 4. And once again, I have a couple equations that I can easily solve. The square root property. First one, x equals positive. Now remember, the square root of negative 9 is imaginary. You're going to rewrite it as the square root of 9 times I, or 3 times I. Right? You're going to have an imaginary unit there. or x equals negative square root of negative 9, or negative 3i, or, and then over here, x equals positive 2 or negative 2, right? The square root of 4 and the negative square root of 4. And then don't forget to check your answers. Now, if I were to plug these in, right, go back to the original equation. Plugging in 3i, that'd be negative 9 squared root of positive 81, right? 3i to the fourth is 81. 3i squared is negative 9, right? X squared would be negative 9. So that's negative 45, and then negative 45 and negative 36 make negative 81. You have 81 minus 81 equals 0. And since these are both even powers, the negative one will work the same way. So 3i and negative 3i are both solutions. Plugging in 2. 2 to the fourth is 16. 2 squared is 4. 4 times 5 is 20. 20 plus 16 is 36. 36 minus 36 is 0. Both of these work as well. You have 0 equals 0. So we have 4 solutions. Right? X equals positive or negative 3i are solutions, and so are positive or negative 2. Right? So there are, again, 4 solutions here. Right? Good. Alright, so after this question, I'm going to have you guys check these on your own. Right? You can do it with, by hand or with a calculator, however you want. Just make sure you're checking your solutions. Great. So yeah, same steps every time. So the next question is, again, very similar. We have another quartic equation. Degree 4 is the highest power of x we're seeing. But it's already set up the way that I want, right, where everything's on one side in descending order and then 0 on the other. So once again, I'll write it so that you can see it's in this quadratic form. This is 4 times, some expression squared, right? So x squared minus 5 times that same expression, x squared to the first power plus a constant, equals 0. So you can see that it's definitely in quadratic form. And now I'll sub. I'm just going to write sub this time, right, instead of substitute, just to save writing. We're going to substitute, right, sub. I'm going to, again, replace x squared. This time I'll replace it with the letter u. Why not? So now this equation becomes 4 times u squared. Right? X squared is replaced with u. Minus 5 times u to the first plus 1 equals 0. Alright, and then once again, we have a quadratic expression here that is factorable. So this is pretty nice. This actually factors to 4u minus 1 times u minus 1. I leave it to you to check that out, right? Okay, and then equals 0. So the solutions of u, right, u equals 1/4. Right, that'll make that factor 0. Or u equals positive 1. Right, so now I got some room to keep it on the same page here. And now we're going to sub back. Right, I've solved for the new variables, but I want to go back and solve for the original variable x. So u equals 1/4 becomes x squared equals 1/4. U equals 1 becomes x squared equals 1. And again, I have some ones here that I can easily solve with the square root property. So x squared equals 1/4. x is going to be positive or negative 1/2. Right, the square root of 1/4. And here x squared equals 1, so x is either going to be positive or negative 1. And check them. That's 4 solutions. And they do all work. I'll leave it to you to check though. So positive 1/2, negative 1/2, positive 1, and negative 1 all work. Great. Alright, number 4, very similar. Pardon me. Another quartic equation, but again, it's set up the way I want, where you see the power of the first term is double the power of the second term, and I got a constant, and equals 0. Alright, so once again, I'll write it so that you can see it's in quadratic form. Right, this is 3 times, some expression squared, x squared squared, minus 14 times that same expression, x squared to the first power, plus 8 equals 0. And I'm going to make a substitution, right? Actually change it into a quadratic equation in some new variable. I'm going to substitute for the x squared again. Right? X squared. I'm going to replace x squared with, r. You don't have to do different letters. You can do the same letter every time. Right? I'm just messing around using different letters. So this becomes 3 times r squared minus 14 times r plus 8 equals 0. And then I solve this for r. Well, again, you can use the quadratic formula, complete the square. But once again, we have a nice factorable polynomial here. This would factor. You'd have 3r and r. Then minus 4 over here, minus 2 here to give me minus 12r, minus 2r for minus 14r, and then you got the positive 8, right? Okay, so r is either 2/3 or r is 4. And I'm taking this over here again. Now we will sub back. Right? I've solved for the new variable, but I want to go back and solve, for the original variable. R was x squared. Right, so we have x squared equals 2/3. X squared equals 4. Using the square root property, x equals positive or negative, right? Now the square root of 2/3, remember the square root of 2/3 when I rationalize it, right? Rationalize the denominator would be the square root of 6 in the numerator divided by, and then 3 in the denominator. I hope you recall how to take the square root of a fraction and rewrite it, so that the denominator doesn't have a radical. I would just multiply the top and bottom by square root of 3. So positive square root of 6 divided by 3, negative square root of 6 divided by 3, those should work, and I leave it to you to check. And x squared equals 4 gives me the two solutions of positive or negative 2. And again, I leave it to you to check these, but they should work. Cool. 4 solutions again. Alright, so these first 4 questions, were all very similar with a quartic equation, a degree 4 equation where I substituted for x squared. But, you're not always substituting for x squared. There's plenty of other equations out there that are quadratic in form, and we're going to see some more next. Alright, so question 5, example 5, exercise 164 from the text. Again, it's set up the way I want, where everything's on one side, zeros on the other. and it's already written in a way where I can tell that it's in quadratic form. See, I've got some expression to the second power, x plus 2 squared in this first term. Then in the second term, I got that same expression, right, x plus 2 to the first power, and then a constant, right, equals 0. So the substitution I'm going to make is for this expression, being squared into the first power here. I'm going to make a substitution. I'm going to replace these x plus 2's, right, with some variable. How about t? Right? I'm going to replace x plus 2 with t. So this becomes t squared minus 3 times t minus 54 equals 0. And once again, we solve this new quadratic equation. You can use the quadratic formula, complete the square, but yet again, this is nice and factorable. This actually factors to t minus 9 times t plus 6. All right, so the solutions here, for t anyway, are t equals 9 or t equals negative 6. But now I'm going to sub back, right? I don't want to solve for t, I want to solve for x. The original variable was x. So instead of t equals 9, it's x plus 2 equals 9. And instead of t equals negative 6, right, it's x plus 2 equals negative 6. And then all I need to do to solve for x here in both of these is subtract 2. So x equals 7 or x equals negative 8. And again, I leave it to you to check those, but they should both be working. Wonderful. Alright, next question, very similar. It's already set up the way that I want, right, where everything's on one side, 0 on the other. Got 3 terms, added up to be equal to 0. And the first term here has, some expression squared. This 5y minus 1, right, squared. The next term has that same expression to the first power. And then you have a constant, so it's in quadratic form. Hopefully it's easy to recognize. So once I recognize that it's in quadratic form, I'll make a substitution. And I'm just going to substitute for that expression that's being squared into the first power in each of these first two terms here. So that's 5y minus 1. I'm going to replace 5y minus 1 with x. Again, just some other variable. So that turns this equation into x squared plus 3 times x minus 28 equals 0. And now I have an equation that's quadratic in x. And I solve this for x. Once more, we have a factorable polynomial here. This factors to x plus 7 times x minus 4, right, equals 0. And we see the solutions in x are negative 7 or positive 4. Alright, but I don't want to solve for x, right? I want to solve for y, the original variable. So once again, we sub back, right, go back to expressions with the original variable. So this equation here, x equals negative 7. Remember, x is 5y minus 1. So this becomes 5y minus 1 equals negative 7. And the other equation is, 5y minus 1 equals 4. And I solve each of these for y. And in both of them, I would add 1 and then divide by 5. So from this first equation, I'd have a add 1 to get negative 6, then divided by 5. So negative 6/5 for that equation. And here, add 1, you get 5, divided by 5 is 1. Y equals 1. And check them, right? Plug them in for y back in the original equation. And I promise you they'll work. But you should still be checking them, though. I'm leaving it to you. All right. Next couple problems are pretty similar. Where the substitution should be obvious. So number 7 here, we got, see everything on one side, 3 terms equals 0. So it's set up the way I want right away. And you see how it's in quadratic form here, right? There's this first term has some expression squared, and the next term has that same expression to the first power, and then a constant. Right? So this is definitely in that quadratic form. So now I substitute, and I'm replacing this expression being squared into the first power here, this x squared minus 4. Alright, I'm going to replace this with, I'll go back to m, whatever. So that turns this equation into m squared minus 4m plus 3 equals 0. And we solve this quadratic for m. And one more time, we have a factorable polynomial here. This factors to m minus 3 times m minus 1. So we have m equals 3 or m equals positive 1. But now I sub back, right? I don't want to solve for m, I want to solve for x, right? The original variable. So now we sub back. Remember that m was x squared minus 4. So this is x squared minus 4 equals 3, or, and then x squared minus 4 equals 1. This would give me x squared equals 7, so x equals positive or negative square root of 7. Alright, so two solutions there, positive square root of 7, negative square root of 7. Here we have x squared equals 5 after adding 4, and I get two solutions from this as well, positive or negative square root of 5. Alright, so 4 solutions, positive root 7, negative square root of 7, positive square root of 5, negative square root of 5. And again, I leave it to you to check that those actually work back in the original equation. Alright, question 8, very similar. Again, it's all set up where I have 3 terms on one side, 0 on the other, and they're in descending order by power. First term has some expression to the second. The next term has that same expression, x squared minus 5, to the first power. So definitely quadratic in form. So I'm again hoping that the substitution is obvious here. I would substitute, for x squared minus 5. I'll replace it with y, right? Whatever, right? Just some other letter. So now this becomes 2 times y squared minus 7 times y, and then plus 6 equals 0. And yet again, we have a nice factorable polynomial. Now again, you can use the quadratic formula to solve for y if you want, but this does factor. Be a 2y minus 2 here, minus 3 here, right? That'd be negative 4y, negative 3y for negative 7y, and then positive 6, right? 2y minus 3 times y minus 2. So the solutions in y, right, y could be 3 halves, or y could be positive 2. Alright, then we sub back. I don't want to solve for y, I want to solve for x, right, the original variable. So we sub back. Remember, y represents x squared minus 5. So the first equation there is x squared minus 5 equals 3 halves. The second equation is x squared minus 5 equals 2. Alright, then I would add 5 to both sides. This first equation becomes x squared equals 13 halves. Right, this is 10 halves, right? You would add 10 halves. You need a common denominator when you add numbers. So you add 10 halves. 3 halves plus 10 halves is 13 halves. And then take the, use the square root property. X is going to be positive or negative. Now the square root of 13 halves, when I rationalize the denominator, multiply the numerator and denominator by the square root of 2, would be the square root of 26 divided by 2. So positive square root of 26 divided by 2, and negative square root of 26 divided by 2. Those are solutions. And again, you check them back in the original with a calculator or something, or by hand. Here, I'd add 5 to get x squared equals 7. So we have solutions positive or negative square root of 7. And again, I leave it to you to check those. 4 solutions, right? These two, these two. Great. All right. So the next questions, it might be less obvious what the substitutions are, but hopefully not. All right, so question 9. We're going to make use of the fact, now this is a radical equation, right? Now you've seen in previous videos, hopefully previous lessons, how to solve a radical equation, right? You isolate the radical term, undo the radical. So, I could do this that way, right? So let's do this on a separate sheet. I could keep the x plus 15 on the left, take the 8 times the square root of x to the right, then square both sides, and get x squared plus 30x plus 225 equals 64x. And then subtract 64x, you got x squared minus 34x plus 225 equals 0. Alright, and then use the quadratic formula, or let's see if this is factorable. That's 15 squared. That's 5 times 45. Let me just think about this for a second. Alright, I'm just going to use the quadratic formula. So we have x equals, positive 34, the opposite of b, plus or minus the square root. Now, I checked it already. 34 squared minus 4 times 1 times 225 is 256. Right, that's the b squared minus 4ac, the discriminant. All this divided by 2. So that's 34 plus or minus 16. The square root of 256 is 16 divided by 2. So I'm getting two solutions here, two possible solutions. 34 plus 16 is 50 divided by 2 is 25. 34 minus 16 is 18 divided by 2, which is 9. And then we check them. Square root 25, and then the square root of 25 is 5. 8 times 5 is 40. 25 minus 40 is negative 15 plus 15 is 0. This works. Plug in 9. 9 minus 8 times 3. 9 minus 24 is also negative 15 plus 15. This works as well. Alright, so that was the old way. Alright, 25 and 9, that's the old way. Now, in this video, right, we're trying to see these things as quadratics. The square root of x is the square root of x. X to the first here is the square root of x squared, is it not? Hopefully that rings a bell. The square root of x squared is x. And then you have minus 8 times the square root of x to the first. And then plus 15 equals 0. So do you see now how this equation, the way it looks at the moment, is in quadratic form? Alright, I've got 3 terms equals 0. First term is some expression squared. The second term has that same expression to the first power. And then you have a constant. So I'm going to make a substitution. I'm going to sub, the square root of x. I'm going to replace the square root of x with z. Right? So now this equation looks like the following. Right? We have z squared minus 8z plus 15 equals 0. And this is again pretty easily factorable. This is z minus 5 times z minus 3. Right, so the solutions of this quadratic equation in z are z equals 5 and z equals 3. Right, but I don't want to solve for z, I want to solve for x, right, the original variable. So we're going to sub back. And remember that z represents the square root of x. So the first equation here is the square root of x equals 5. This second one is the square root of x equals 3. And then I square both sides. We get x equals 25 or x equals 9. Right, squaring both sides of those. And then we already checked them. Right, I already checked them. 25 does work. And 9 does work. Right. And these are exactly the same solutions I got doing it this way, right? Solving it the way you would solve a radical equation normally. 25 and 9. But the numbers were even smaller here, right? This actually was pretty easy compared to the original way. Right. Great. So the next question is very similar. Again, we have something that's a radical equation. Now you could solve this by getting the radical term on its own side, squaring both sides, solving the resulting equation, then checking your solutions. But hopefully you can recognize this as something that's in quadratic form. Right, I got 3 terms here, equals 0. X to the first power. Remember the square root of x can also be written as x to the 1/2 power. So you see x to the first power, that power is double this power of x, right? This is x to the half. So that's what happens in quadratic form, right? The power in the first term is double the power in the second term, then we got a constant equals 0. So once again, I'm going to write this as I did in the number 9, right? X to the first is the same thing as the square root of x to the second. Plus, and then we have 4 times, that same expression, the square root of x to the first. And then minus 21, equals 0. And then I'll make my substitution for the square root of x. I'm going to replace the square root of x with y. Right, why not? So now the equation becomes, y squared plus 4 times y minus 21 equals 0. And this is factorable again. This is y plus 7 times y minus 3. Right, so my solutions for y are y equals negative 7 or y equals, positive 3. Right, now we're going to sub back. I want want to solve for the original variable x. So y was the square root of x, right? So the square root of x equals -7, which won't have a solution. Alright, well, won't have a valid one. You'll see. Or square root of x equals 3. Remember, when you see the square root symbol, remember that means they want the non-negative root. So how can a non-negative number be equal to a negative number? This has no solution. Right? This actually has no solution. Now if you squared both sides and said x equals 49, but then, doesn't work when you put it back into that equation, you see there's no solution coming from that first equation there. And even if you were to check 49 back in the original equation, 49 plus 28 minus 21 is, 66, I think, right? 49, no, 56. 49 plus, 4 times 7, square root of 49 is 7. 49 plus 28 minus 21 is 49 plus 7. That's 56 equals 0. So I'm not getting any solutions from this equation here. Alright, so be careful, especially with even roots. Remember, even roots were tricky. This one, though, the square root of x equals 3, if I square both sides, you get x equals 9, which is a valid solution to that equation. And then if I were to check this back in the original, you'd have 9 plus 12, which is 21, minus 21 is 0. That definitely works. Right, so there's only one solution. Right, only one solution, 9, not 49. Right? This first equation here, right, had no solutions. But this one does, and it does work back in the original equation. So the only solution to this question here is x equals 9. Great. All right, next couple questions are very similar with the square roots here. Similar substitutions. Alright, so again, for number 11, you have 6 times x, which I'm going to rewrite as 6 times, the square root of x squared. Plus, and then we have, the square root of x to the first, minus 1 equals 0. So again, 3 terms equal to 0, the way that I want it. The first term has, some expression squared. The second term has that same expression to the first power. And then you have a constant, right? So I'm going to sub for the square root of x again. I'm going to replace the square root of x with n. Whatever you want, as long as it's not x again. So this becomes 6 times n squared plus n minus 1 equals 0. And this actually factors, yet again, you can use the quadratic formula if you want, but this factors to 3n minus 1 times 2n plus 1. Right, because you got 3n minus 2n for 1n and then negative 1, yep. Alright, so the solutions in n are the following. N equals 1/3 or n equals negative 1/2. Alright, but then I sub back. And we get the square root of x equals 1/3 or the square root of x equals negative 1/2. But please understand that this has no solution here. Right, the square root of a number can't be negative, right? Remember, this symbol means the positive square root. So something that's non-negative can't be negative. Now, if you were to try and say, oh, x equals 1/4, right? You square both sides. This doesn't work. All right. And even if you went back to the original equation, it wouldn't work. 6 times 1/4 is 1 1/2. plus the square root of a quarter is a half. That's 2 minus 1 equals 0. That's false, right? So you're not getting a solution from that equation, but you will from this one, right? You square both sides here, you get x equals 1/9. And then check that, 2/3 plus 1/3 is 1, 1 minus 1 is 0. Fantastic. Right? So 1/9 is the only solution here. Alright, number 12, same setup. Again, I'm going to rewrite x as the square root of x squared. Then we have plus 5 times, the square root of x to the first. Then minus 3 equals 0, right? So I'm going to make a substitution. It's definitely in quadratic form. So I'm going to sub for the square root of x again, right? The square root of x equals, m. So this becomes 12m squared plus 5m minus 3 equals 0. Alright, and then this is another factorable. This is another factorable polynomial. This would factor to I think 4m and 3m. And plus 3 here, minus 1 there, right? That would be 9m minus 4m for the 5m, and then you got minus 3. So the solutions here are negative 3/4 or positive 1/3. Right, and then we're going to sub back. Solve for the original variable. Right, solve for x. So the first one is, the square root of x equals negative 3/4. And once again, this equation, this particular equation here, has no solution. And even if you were to square both sides and get 9/16, it won't work in the original equation, I promise you. Right. Or, and then here, square root of x equals 1/3, square both sides, x equals 1/9. Now, we can check that, right? Now this would be 4/3 plus 5/3 is 9/3, which is 3 minus 3 is 0. 1/9 works. Right. So the only solution is 1/9. Again, if you got 9/16, 9/16 would not work. Right, because that'd be 27/4 plus 15/4. It'd be way bigger than 3, then minus 3 wouldn't be 0. Right? So again, you're not getting anything from this square root equal to a negative number stuff. But when the square root's equal to a positive number, you get a solution out of that. Right? 1/9. Great. Alright. So that's it for those square root ones. But again, there's all sorts of equations that are quadratic in form. Right? So look at number 13 here, exercise 180 from the text. See, I've got a term with a power of 2/3 and another with a power of 1/3 on the same expression, right? X to the 2/3, x to the 1/3. You see how that power is double this power? And I'll subtract 28 here to put it in the form I want, where everything's on one side, 0 on the other. Right. And what I'm going to do here is, I'll rewrite it so that you can see it's in quadratic form. Right? X to the 2/3 is x to the 1/3 squared, right? Using that power to a power rule. Minus, and then you have 3 times, and then x to the 1/3 to the first power. Then minus 28 equals 0. So you see this is in quadratic form. It's, the first term has some expression squared, the next term has that same expression to the first power, and then a constant, and then equals 0 there. So I'm going to sub for this x to the 1/3 power. Now remember, x to the 1/3 power is also the cube root of x, right? If you want to use that, you can as well. You can change this all to the cube root. Right? X to the 1/3 is the cube root of x. But I'll leave it as x to the 1/3. And I'm going to replace x to the 1/3 with u. Why not? Right, whatever letter you want, as long as it's not x again. So this becomes u squared minus 3 times u minus 28 equals 0. This factors to u plus 7 times u minus 4 equals 0. And the solutions in u are -7 and +4. Alright, but now I sub back. I'm just going to stop changing color here. Let's sub back. Remember, u was, the cube root of x, x to the 1/3. So if x to the 1/3 equals -7, or x to the 1/3 equals 4, and then you would cube both sides, right? Raise both sides to the third power. X equals, now -7 to the third power would be -343. Right? 7 times 49, 280 plus 63, yeah. And, raise both sides to the third power. 4 to the third power is 64. Alright, and then don't forget to check these. Alright, so -343 for x. Cube root of -343 is -7. -7 squared is 49. So you have 49. And then plus 21. Doesn't look like that works. Alright, check it again. Yeah, -343. The cube root would be -7. Squared would be 49. And then the cube root of, again, -343 is -7. So 49 plus 21. Alright, so this does not work. This is an extraneous solution, which you've seen already, right? I just didn't write the word extraneous before. Now how about 64? This is why you check your solutions, right? And how about 64? Cube root of 64 is 4. 4 squared is 16. And then 64. Looks like this fails as well. Oh, you know why it failed? Because I messed up. Haha. Alright, so see, this is why I'm checking. This is why I always check. But look, you may have been screaming at me. This is not how that factors. U squared minus 3u minus 28 doesn't factor to u plus 7 times u minus 4. It's u minus 7 times u plus 4. Alright, so you know what? I apologize for that. But this is why you check your answers, folks. This is why you check your answers. So I'm going to go back to that area where I substituted. Alright, this was u squared minus 3u minus 28 equals 0. And then let me factor it correctly this time, huh? This would be u minus 7 times u plus 4 equals 0. So we get u equals 7 or u equals -4. Then we sub back x to the 1/3 equals 7 or x to the 1/3 equals -4, and then cube both sides. You get positive 343 or -64. Now let's check them. Alright, now let's check them. I totally apologize for that. Alright, 343. This would again be 49, but this time it's 49 minus 21, which would be 28. So 343 does work. So my apologies again. Ignore everything I did up there. Alright, then -64. This would be positive 16, and then plus 12 would be 28. Absolutely. Alright, so these work. I am so sorry yet again. So this is why you check your solutions, right? This is why you check. Try to fix your mistakes. See if you can find mistakes. So yeah, so the solutions to number 13 here are 343 and -4, -64. both of those work. Wonderful. Alright, so again, my apologies for the bad factoring. Alright, next question. Same stuff. You see x to the, now it's already everything on one side, 0 on the other. So, x to the 2/3 you can think of as x to the 1/3 squared minus 11 times, that same expression, x to the 1/3 to the first power plus 30 equals 0. Alright, then we sub to put it in, write it as a quadratic. I'm going to replace x to the 1/3 with n. So now this equation becomes n squared minus 11n plus 30 equals 0. Again, we have a nice factorable quadratic here. This factors not, hopefully I'm doing it right. This factors to n minus 6 times n minus 5. That is correct. I'm going to double check that, yeah. Equals 0. So my solutions for n are n equals 6 or n equals 5. But then we sub back. And I want to solve for the original variable. So n was, x to the 1/3, right? The cube root of x. So x to the 1/3 equals 6, or x to the 1/3 equals 5. And then cubing both sides, we get x equals 216, right? 6 cubed. Or 5 cubed, right? X equals 5 cubed, which is 125. And let's check these. 216, this would be 36, right? 6 squared. 36 minus 66 would be negative 30 plus 30 equals 0. Absolutely. So 216 works. And 125, this would be 25. 25 minus 55 be negative 30 plus 30 equals 0. This works also. So 216 and 125 are the solutions of that equation. Okay. So good, I didn't make any errors on that. Alright, next page has some very similar ones. And very, very similar ones, again with the x to the 2/3 and x to the 1/3 power. Alright, so you know what, I'm just going to make the subtract 8 and write this so that you can see it's in quadratic form. It's 3 times, x to the 1/3 squared minus 10 times x to the 1/3 to the first power, and then minus 8, equals 0. Definitely in that quadratic form. I'm going to substitute. I'm going to let, x to the 1/3 be replaced by, y. Now this equation becomes 3y squared minus 10y minus 8 equals 0. And then again we have a nice factorable polynomial. Let me actually factor it correctly. So minus 4 over here for minus 12y, and then plus 2 here for plus 2y to make the minus 10y, and then you got minus 8. This is 3y plus 2 times y minus 4. And the solutions then are y equal, the solutions in y anyway, are negative 2/3 and positive 4. Alright, but I want to sub back. Remember, y was x to the 1/3, so this is x to the 1/3 equals negative 2/3, or x to the 1/3 equals 4. Then I would cube both sides, so x equals negative 8/27. Here, cubing both sides, x equals 64. Alright, and I leave it to you to check these. Right, I've checked a bunch, but these should work. Okay, these should work out. Alright. Pardon me. Alright, next question. Okay, next question. Same thing. You know what? I'm just going to make the substitution right now for x to the 1/3 power, because this is x to the 1/3 squared again. Alright, so I'm going to let x to the 1/3 be replaced by t. And this equation becomes 20t squared minus 23t plus 6 equals 0. Alright, a quadratic equation. And then, let's see if this is factorable. I'm going to pause it for a second. Alright, so I do see how this can factor now. Playing with it in my head for a little bit. This would have to be 5t and 4t for the 20t squared. And then I need a minus 3 over here for minus 15t, minus 2 here for minus 8t to make minus 23t, and then negative 2 times negative 3, positive 6. Alright. And then the solutions in t are 2/5, positive 2/5, and positive 3/4. We sub back. Let's put back. Right, sub back. T was x to the 1/3, right? The cube root of x. So we have x to the 1/3 equals 2/5, or x to the 1/3 equals 3/4. Then cube both sides. So here we have x equals 8 over 125. Here, cubing both sides, raising both sides to the third power, that'd be 27/64. And being that these are odd roots, cube roots, right, you should be able to plug in anything. These should work out, right? And I didn't factor in correctly, like in number 13. Right, like in question 13. So these should work, and I leave it to you to check them. Right. The only time I'm really worried is when we have even roots or denominators that could be 0, stuff like that. Alright, next question. Alright, next question, we're back to an even root one, right, a square root. So this is 2 times x minus 7 times x to the half. Remember, x to the half is the square root of x, right? I wrote that earlier. So this is just like earlier problems, right? So we have 2 times, x to the first is x to the half squared, isn't it? Right? Or the square root of x squared. Minus 7 times x to the half. Then I'll subtract the 15 and get everything on one side, 0 on the other, like I've been liking for all these problems. And you can hopefully definitely see that it's in quadratic form. So now I'm going to sub this x to the half. Right? I'll replace it with y, right? Something else, right? Some other letter. So this becomes 2 times y squared minus 7 times y minus 15 equals 0. And this is factorable. I can see it right away. We have 2y and y. And I would need a minus 5 over here for the minus 10y, plus 3 here for plus 3y to make minus 7y, and then 3 times negative 5 is negative 15. Alright, so I factored that correctly. Goodness. And y equals negative 3/2, or y equals 5. Then we sub back. Right, sub back. Get x to the 1/2 equals negative 3/2. Now remember, this is like the square root of x equals negative, which is bad. So we're going to see that this will end up giving us a solution that doesn't really work, an extraneous solution. We'll see that in a second. X to the 1/2 equals 5. Squaring both sides, you get here x equals 9/4. Here you get x equals 25, but definitely check them, right? This actually doesn't work. Right, watch. Put it back into the original equation. 2 times 9/4 would be 9/2. Again, the square root. This is the square root, so non-negative. 9/4 to the half is 3/2. That's 21/2. So 9 halves minus 21 halves would be, negative 12 halves, negative 6. That's not equal to 15. Right, that is not equal to 15. So this is extraneous. You're not getting any. So this is, again, just like the square root of x equals a negative. You didn't get any solutions from that. Right? So 9/4 doesn't work. But 25 does. 50 minus 35 equals 15. That is correct. Right? So the only solution to this equation is positive 25. Right? Great. Okay. The next question, now this is a little different, right? We haven't seen these yet with negative powers, but notice it's got that form, that quadratic form. 3 terms on one side, 0 on the other. And you see the power on x, the power on this expression in the first term is negative 2. The power on x in the second term is negative 1. So this term's power is double this term's power, just like in the quadratics, and then you have a constant. I can rewrite this as 15, and as I can write x to the negative second as an expression squared, right? X to the negative first squared minus 26 times that same expression, x to the negative first to the first power, plus 8 equals 0. So again, hopefully you can recognize the quadratic form, right? First term has some expression to the second. The next term has that same expression to the first, and then a constant, and then equals 0. Alright, so now I make a substitution for this expression. We're going to sub for x to the negative first. And everywhere there's an x to the negative first, I'll replace it with m, right? Whatever, just some other letter. And we change it into a quadratic equation. 15 times m squared minus 26 times m plus 8 equals 0. And then let me think, is this factorable? Yeah, absolutely. Right. Yes, it is. So, let me see if I can factor this correctly just by guessing and checking here. I would need 5m here, 3m there, then minus 4 over here to give me minus 20m, and then minus 2 for minus 6m for minus 26m, and then you got positive 8, right, when you multiply the negative 2 and negative 4. So yeah, this factors a 5m minus 2 times 3m minus 4. Great. So the solutions in m are 2/5 and 4/3. Alright, but then we sub back. So we have x to the negative first equals 2/5, or x to the negative first equals 4/3. But remember, x to the negative first is just 1 over x. 1 over x equals 2/5, same thing. X to the negative first is 1 over x. 1 over x equals 4/3. So all I need to do to solve for x is just take the reciprocal of both sides. You get x equals 5 halves, or x equals 3/4. And let's see, yeah. Those should both work. I'll leave it to you to check though. Right? 5 halves and 3/4 are your solutions to this equation. Wonderful, wonderful. Alright, and finally, one more question, just like this with the power of negative 2 and power of negative 1 showing up. Alright, question 19, exercise 192. Same setup, everything on one side, 0 on the other, and it's definitely in quadratic form, right? The first term has a power that's double the second term power, and then you got a constant. Alright, so I'm going to sub for this x to the negative first again. I'll call it, I'll just call it y. And this first term, 15 times x to the negative second, right? X to the negative second is x to the negative first squared. So this would be 15 times y squared. Minus 4 times x to the negative first to the first, so just, y. And then minus 4 equals 0. And then let's see, yeah, this is another factorable quadratic. Let me think. I would need negative 10 and 6. All right, so 5y here, 3y here, and minus 2 here for minus 10y, plus 2 here for plus 6y, minus 10y plus 6y would be minus 4y, and then 2 times negative 2 is negative 4. All right, so this factors to 5y plus 2 times 3y minus 2 equals 0. Solutions then for y are y equals negative 2/5 or positive 2/3. And then we sub back, meaning x to the negative first equals negative 2/5 or x to the negative first equals 2/3. And then just like in question 18, remember x to the negative first is just 1 over x. So if I just either raise both sides to the negative first power or just take the reciprocal of both sides, that means the same thing. So x equals negative 5/2 or x equals 3/2. And both of these should work, and I leave it to you. And let me think there for a second. Yes, indeed. Yes, they both work. So, but I leave it to you to check. Right? You should be checking your solutions every single time. Because again, if you check your solutions, you're like, hey, this doesn't seem right. Maybe you made a mistake, and you go back. That's exactly what happened with question 13 here in this video, right? You saw me make that error, and I realized that I made a factoring error and went back and fixed it. And so there's a good lesson for you, right? Always be checking your solutions, double check your work to see if you can catch any minor errors and then fix them. Great. All right, so hopefully watching me go through these 19 questions, 19 examples of solving equations in quadratic form help you when you're doing it on your own. Right? You're doing the same thing every time. Once you recognize that it's in quadratic form, make a substitution to change it into a quadratic equation, solve that quadratic equation, then substitute back and solve for the original variable and check your solutions, right? It's a lot of stuff, but again, as I said, I'm hoping that watching me go through these here help you out when you're asked to solve equations in quadratic form on your own. All right, and thank you very much for watching.